Hey guys, Miss Miklos here with our next exciting lecture. In this lecture, we're going to be talking about graphing linear inequalities. And just a few reminders before we get going. We have our lovely inequality symbols over here. And there's really two things we need to remember. If it's less than or greater than, we need to have a dashed line. And if we have an equal to, that means our line is solid. And just kind of to explain why, if we have a solid line, that means that every single point on that line is a solution to the particular inequality. If it's dashed, that means any point on that graph is not a solution. Okay, kind of like when we had a parenthesis and it was showing all the solutions up until that particular point, that's like a dashed line. Having a bracket was like how our solid line is going to be. The other thing that we're going to be doing is shading our solutions, okay? Because we know whenever we see an inequality, shading should kind of pop into our minds. The other thing that we need to remember with inequalities is that whenever we multiply or divide by a negative, we need to reverse our inequality symbol. So our steps for today, the first thing we're going to be doing is graphing the line, just like we did a few lectures ago. And just a reminder, on every single line today, we should be writing m equals and b equals. Then the only new thing we're really doing, other than when we graph the line, we need to think, is it solid, is it dashed, is that we need to test for shading. And the way that we test for shading, we substitute any point not on the line. My personal favorite is 0, 0 because it causes me the least amount of work, which I would always prefer to do. So that is about it for today. So let's get into some of our examples. So our first example here is y is greater than or equal to -3. So we need to go ahead and graph this first. We know any y equals line is a horizontal line at -3. Since it says greater than or equal to, I'm going to go ahead and draw a solid line. Okay, remember I have arrows on both sides. Okay, here my slope is 0. My y-intercept is -3. And if we look at this, I think this is the one where it's really easy for us to determine where are all of our solutions. Okay, if I substituted in 0, 0, I would not substitute in an x value because it is just y is greater than or equal to -3. So I would need to see, okay, is 0 greater than or equal to -3? And it is. So I am shading everything up here. And that's telling me these are all of our solutions. Our next one is pretty similar. We have x is less than or equal to 2. Okay, I know our x equals line. We say our slope is no slope, or we could also say it is undefined. And for our y-intercept, there is none. Excuse me. Because it is not going to cross the y-axis at all. So this time I have a less than symbol, so I know that I need to draw a dashed line. So I'm going to go at x equals 2, and I'm drawing a dashed line. And once again, I need to figure out where are all of our solutions. So I'm going to substitute in 0, 0. Okay, 0, 0 this time is to the left, so if this works, that means I'm going to shade over here. If it doesn't work, I'm shading to the right. So I'm going to say, is 0 less than 2? And it is, so I know that I'm shading everything here to the left of our dashed line. So those first two examples were pretty simple, pretty straightforward because they were just our horizontal and vertical lines. With number 3, we're getting into some tougher ones. Y is greater than or equal to x. So this is in slope-intercept form, so I'm going to go ahead and use slope-intercept form to find our slope. Our slope would be 1 because that is the coefficient of x. My y-intercept would be 0 because we're not adding anything here. So when I'm graphing this, I know that our I know that our line itself is going to be solid. So I'm going to put a point at 0, 0, and a slope of 1 tells me to go up 1 and over 1. And I'm going to go ahead and draw that line. Now this time, I actually cannot substitute in 0, 0 because it's on our line. So I need to choose a point not on the line. For example, let's try 0, 1. Okay, 0, 1 is right here, so if 0, 1 works, I would shade here. If it does not work, I'm shading on the other side. So I'm going to say 1 is greater than or equal to 0. That is a true statement. So I'm shading everything on that side of our line. Number 4, here we have to deal with an inequality that is in standard form. Just a reminder, in standard form, the way we find slope is the opposite of A over B. Our y-intercept is C over B. Or I could always change this into slope-intercept form if we wanted to. My slope here would be the opposite of 4 over 2, which would be -2. My y-intercept is C over B, so 8 over 2, which is 4. So if I'm graphing this line, I'm going up to 4. Okay, and just a reminder, that means that that is an ordered pair of 0, 4. My slope of -2 means I'm going to go down 2 and to the right 1. I also could have gone up 2 and to the left 1. And I'm going to draw my line. Okay, and I just want to double check, how did I know that my line should be solid? And that's because of this inequality symbol. When I substitute 0, 0 in, if it works, I'm shading over here. If it doesn't work, I'm shading on the other side. So I'm going to do 4 times 0, there we go, plus 2 times 0 is greater than or equal to 8. Is 0 greater than or equal to 8? And of course, we know that answer is no. So I'm going to shade on the other side. So everything kind of to the right there of that line is a solution. A good way to double check if this was like on our test, I might pick an ordered pair over here and substitute it in just to make sure that it works. Okay, because I know shading or solid lines mean that something is a solution to the equation, or in this case, to the inequality. And our final example, as you can kind of see, this is pretty straightforward. It doesn't get too tricky. We don't have to deal with more than one inequality at a time. We'll get into that next chapter. But my slope on this particular problem would be the opposite of 3 over -2. Which is positive 3 over 2. My y-intercept would be 9 over -2, or -9/2. Now, just a reminder, it might help us if we remember that that is like -4.5. That is an exact value. And when we're graphing, sometimes it's easy to think of things in that way. So I'm going to begin at -4.5, and from there I need to go up 3 and to the right 2. Now this time, my line is going to be dashed. Okay, and that's kind of an awful line, but you can get the whole point of that. The reason why it's dashed is because anything on that line is not a solution because of this inequality symbol. When I substitute 0, 0 in, 3 times 0 minus 2 times 0 is greater than 9. Is 0 greater than 9? Of course not. So that means that I'm shading everything to the right of that inequality line. So these are all of my solutions. Now, just to remind us the way I can double check that I graphed this correctly, since this is rising from left to right, I know we should have a positive slope, and if we look over here, we do. So we are in good shape. If I wanted to double check these, I might substitute in like 5, -5, or something like that into this inequality and make sure that it makes a true statement.